A man looks out from the screen and moves his eyes from side to side.
Vision is the dominant sense for most people with sight. The organ of sight is the eye. Think of it as a slightly irregular, hollow sphere that takes in light and translates it into images.
An enlarged image of the eye fades to an eye out of its socket, a large white orb with the eyeball front and center and smooth muscle attachments on top, bottom, and each side.
If we enlarge the eye and look inside it, we can discover how that's done.
A vertical cross-section of the eye shows its internal structures.
Inside the eye are various structures working together to create an image the brain can understand. Among these are the cornea, a clear dome-like structure covering the iris or colored part of the eye, the lens directly below it, and the retina, which lines the back of the eye. The retina consists of thin layers of light-sensitive tissue.
There's a lighted candle in front of the eye.
This candle can help us understand how the eye captures images and then sends them to the brain. First, the candlelight passes through the cornea. As it does, it's bent or refracted onto the lens. As the light passes through the lens, it's bent a second time. Finally, it arrives at the retina, where an image is formed.
Two lines, one representing the top and one representing the bottom of the candle's image, converge as they pass through the cornea and lens and then intersect halfway through the eye. From there, they spread apart as they continue to the retina.
This double bending, though, has reversed the image and turned it upside down. If that was the end of the story, the world would always appear upside down. Fortunately, the image is turned right side up in the brain.
The cross-section of the eye shrinks, and a long cable-like structure labeled optic nerve goes from the back of the eye to a connection at the back of the brain.
Before that can happen, the image needs to travel as impulses along the optic nerve and enter the brain's occipital lobe. When the image forms there, it regains its proper perspective.
Yellow bars representing impulses slide along the nerve to a highlighted lobe at the back of the brain. The candle's image appears upright in the lobe.
Now let's consider two common conditions that cause blurry vision.
The cross-section of the eye enlarges. The nerve and brain are no longer on screen.
The eye's shape is important for keeping things in focus. With normal vision, light focuses precisely on the retina at a location called the focal point.
Light from the candle bends as it passes through the cornea and lens. Once through the lens, it comes to a single point on the retina.
But what happens if the eye is longer than normal?
The eye stretches lengthwise.
The longer the eye, the more distance there is between the lens and retina. But the cornea and lens still bend light the same way. That means the focal point will be somewhere in front of the retina rather than on it.
The light comes to a focal point and then expands before striking the retina. The candle appears blurred.
This makes it difficult to see things that are far away. A person with a long eye is said to be nearsighted. Glasses with concave lenses can correct nearsightedness.
A concave lens, which is curved like a bowl, is placed in front of the eye. The light through the added lens is bent outward.
The lens widens the plane of light coming through the cornea. That pushes the focal point back onto the retina.
The image of the candle is now clear.
Farsightedness is just the opposite. The eye's length is too short. When that happens, the focal point is behind the retina, so it's difficult to see things that are up close.
The image of the eye is squeezed, so the distance from lens to retina is now shorter. The focal point is behind the retina, and the candle's image is blurred.
Glasses with convex lenses narrow the plane of light. Narrowing the light passing through the cornea moves the focal point back onto the retina and can correct farsightedness.
A convex lens, shaped more like a football than a bowl, is placed in front of the eye. It squeezes the plane of the light from the candle, shortening the distance the light needs to come to a focal point. The candle's image is now clear.